Good evening. Hello. I am Wolf Mangelsdorf. Let me just go through this straight away, a little bit about me. I'm a partner at Buro Happold. We're a multidisciplinary engineering firm. You may have heard of us, you may not. Based in London, based offices around the world. And I was here for 15 years, I think, on a journey with Mike. From 2000 to 2015, first technical studies in diploma school, and then many years at MTech. Very enjoyable years. And that ended in 2015, and then in 2021, I became professor of structural design at the Angewandte in Vienna. I should say I'm a structural engineer by background, yeah. And you will hear me talk about that particular thing tonight, but we get to that, yeah. So, but yeah, my firm it's the smallest of the big engineering firms, let's put it this way, yeah. So, you know, when you hear sort of about WSP and all these kind of behemoths, right? There's 100,000 people with 3,000 worldwide. Arab for comparison is about 15,000. So we're small, but big, yeah. We're big because we are present across the world. You can see that with quite a big presence in the Middle East. That is something that will come through all the time when you see also work that's being done at the moment. Yeah, I think that's an interesting one. We started there in the 70s, basically, with Frei Otto. That's where we go back to. Anyway, I'm not going to go through the history of our firm, but yeah, we have a bunch of projects across the world that you may recognize. Yeah, the High Line, Beijing Airport, Olympic Stadium, Battersea Power Station, the British Museum, to name a few on that sheet. And some of them are mine. I've worked on those, and I had a great fortune to work with some of the best architects in the world, and on some of the most challenging projects, like lifting the Cutty Sark 3 meters in the air, and Beijing Airport, or this project there, BR headquarters. I just come from there. I saw the client there yesterday. And as a company, like we saw this earlier, yeah, in Brigitte's quite thought-provoking talk. There's been a movement over the past, say, 5 years that has brought all the sustainability questions much more to the fore. For us, they've been driving questions for the past 40 years or almost 50 years of our existence. They've always been at the forefront of what we're doing. But the route to zero carbon, this push for zero carbon, I would say started sort of 2018, 19. Before that, nobody really wanted to know. And we've enshrined that into our own route map to zero carbon, our sustainability strategy. And here you will see something interesting, because while we are committing to net zero carbon in operation by 2030, we're committing to 50% reduction of embodied carbon, because materials are the problem. They're really the biggest problem. Everything we do kind of sits in this kind of extract, build, throw away quite often economy that Brigitte was talking about. And this is sort of the points where we accumulate carbon, embodied carbon or carbon in general in the construction industry. And we heard the percentages, they vary. I'm a little bit more on the, say, timid side. I say it's 39%, not 41%, but 40% is sort of the number of the contribution of what we do and what we as architects and engineers are directly involved with greenhouse, I call it greenhouse, or GHG, right? That's what we call it, greenhouse gas emissions. They're measured in CO2 equivalent, but they're more than, yeah, there are other greenhouse gases that play a role in that. So the industry had started talking about greenhouse gas emissions. But if I split this further, this is the real culprit here. Building materials and construction itself is 11% of the total, yeah? more than a quarter of our contribution in general. And that's become also more evident because over time we've been able to decarbonize the grid, to be more energy efficient in what we're building. And so over the years, look at the bar chart on the left, 1980, 2005, 2030. Over the years, the contribution of operational carbon in all of this story has become smaller and smaller. It's still big, but if you look at a life cycle carbon footprint of a building, the embodied carbon has come into the fore really as the big culprit. And you can also see on the right-hand side, it hasn't changed over time. This is a bit of a chart that you may be familiar with of, again, we measure it in carbon dioxide equivalent emissions per kilogram, in kilograms per kilogram. So aluminium is 11.5 kilograms of carbon emissions per kilogram of material, if it's virgin material, if it's extracted from the ground. And there's a whole lot of them, more or less all of them play a role in construction, but I'm going to focus on steel, 2.7 per kilo. Cement and concrete. Here's an interesting one, because cement is the real culprit. I'll come to that in a moment. A kilogram of cement is a kilogram of carbon. If you then mix it into concrete, it becomes a lot less, because concrete is a mix of materials. And then the third one I want to look at is timber. And timber is often sold as carbon positive or negative. I don't even know which way around you want to look at it. Basically, it's got no carbon footprints, actually good for the environment if you build in timber. I don't quite believe it, and I'll show you why. I'll bore you a little bit with chemistry, because that's where it all starts. Cement and concrete. Concrete is a mix of cement, water, aggregate, all mixed together, and that then becomes something that hardens because of a chemical process. But in order to get there, you take limestone and clay, you fire it up to 1400 degrees, and you blast the CO2 out of the limestone. So you cannot make CO2 emissions-free concrete by simply heating it with something magic and renewable that would heat it up to 1400 degrees. That is the other problem. No renewable energy actually at the moment is able to bring you up to these kind of levels of heat. Any kind of electrical heating coil would just melt at that point. So you have to blast hot air into this thing, and out comes CO2. That's the biggest problem here. And if you add it all up, concrete is responsible for about 8% of global carbon emissions. That's more than twice aviation, similar to, well, only one other material. I'll get to that. But concrete's been the sort of wonder material, right? It starts way back in Roman times. You've seen that, the dome above the Pantheon is actually made from a concrete, a cement-type material. And it sort of got us hooked, basically, because we can do things that are beyond anything, right? Hennebich's structural systems from the 1880s then started turning concrete into a structural material, initially sort of tectonically, maybe a little bit like your standard metal or timber structure, but it's really these kind of long span structures, Maya Salgina Double Bridge, or the shells that Heinz Isler built that make concrete into this sort of wonder material, a material that can be formed, that can be architect's dream, basically. It doesn't always move. Or this one. But ultimately, what makes concrete so versatile is that you can build what you see here on this rather weird picture, but it shows so nicely the flat slab, right? You can just stack floors, and that's what it looks like in the end. We blast this out. This is KFD in Riyadh, the King Abdullah Financial District. Hundreds of towers built within the space of 5 years in an area where there was nothing. But concrete is cheap because it's made out of limestone. The whole of Saudi Arabia is limestone. Yeah, all you need to do is fire it up and turn it into cement. Similar story with iron and steel. In order to get iron made out of ferrous oxide, you have to blast the oxygen out of the ferrous oxide. And that's a chemical process, and the best way to do that is with carbon monoxide. So you take carbon monoxide, you blast it through a blast furnace, and out comes CO2, and the bottom drops out raw iron. That then needs to be turned into steel. That's another process that uses huge amounts of heat. And in the end, that part of the industry is an equal 8% of total carbon emissions. So an equal offender to cement, slightly easier to go about the reduction of iron and make that out of hydrogen, only that we don't have hydrogen at this moment in time that is fully made out of renewable sources. Yeah? If you then take the hydrogen that's split out of the methane, then you're actually worse off than doing with coke. And I'm sorry, this is where the chemistry lesson ends. But I think we need to go through this because I hear it ever so often that if we just made concrete with renewable energy or cement, then the problem would go away. No, it doesn't. Yeah. And steel is equally a wonder material, an architect's and engineer's dream. Yeah, I think it was the engineers first who kind of discovered it. Frankfurt Central Station, yeah, I could have used a picture of Paddington or any one of those, yeah, these kind of cathedrals of the 19th century, absolutely amazing structures. Or then later, yeah, again, the desire to stack floors. This is probably environmentally the worst building in the world and still one of my favorites. Lakeshore Drive Apartments, Mies van der Rohe in Chicago. Apparently in winter, it either freezes, it freezes in winter and you boil in summer. So all sinkly glaze, but anyway, different story. But we could then drive this material again to complete new typologies. The Millennium Dome structure that we built in 2000 kind of shows that. Strangely, the air it contains is lighter than the material it has, but it's still a lot of steel, and without steel it wouldn't be possible. This one here, slightly different approach, one of mine, yeah, the Glasgow Riverside Museum. I think we use quite a bit of steel in order to achieve that shape and cheat gravity and show that engineering can support a very capricious architecture, if I may put it this way. I've worked many years with Zaha, and it was always a real challenge and a real fun, yeah. But it's somewhat, if I think about it in retrospect, it comes at a bit of a cost, possibly, yeah. This is probably the most extreme of them all. Again, a Zaha project, you may have seen this, is just about getting ready. This is this metro station for all these towers that I showed you earlier. And that thing on the outside that looks as if it's made out of concrete, it isn't actually concrete. It's just clad in concrete. It's steel, and a lot of it, yeah. So steel is incredibly versatile for a structural engineer to do whatever with it. It's a beautiful material in that sense, but this is sort of peak steel sculpture, I would say. And again, it comes back to actually just stacking floors, as I said. This is a project that I did years ago in the city. Massive banking facility. Just floors one on top of each other. And the reason why I show you that is because at the time, in 2012, we did a life cycle carbon assessment. And used our engineering to take some carbon out, reduce it in some areas. But you see that here, that number up there, 88,000 tons of carbon in this building, which equates to roughly 840 kilograms per square meter. That's a lot. Interesting also, when we did this, British Land paid us to do this study. And after the project was over, I went to the sustainability director at British Land and I told her that we should do this on all buildings. And she said, no, this was a one-off, No one's really interested in embodied carbon. That was in 2012, right? I don't know. She's no longer at British Land, and she will probably eat her hat or something, yeah? But it has become something incredibly important. We do these life cycle assessments now on every building. The third material I wanted to look into is timber. And I told you, timber isn't that sort of wonder material that you think, or we are made to believe it is, because it actually starts off as trees, but then it goes through a massive industrial process from kiln drying to glue laminating to transport and all the rest of it. It is an engineered product. It is not necessarily a natural product anymore when it comes to our construction site. So there is a processing, an embodied carbon in that whole kind of way of how we deal with it, and a lot of chemicals involved in that. I'm not saying it's a bad material, but it isn't carbon zero. We try to get as close as possible to carbon zero. We've used that a few times in examples, Mike, right? And I went to Stuttgart, to Achim's AAG conference. I gave a keynote there, and the three people before me, they were doing timber grid shells. Would you believe it? I said, look, guys, go back to the 1980s and 90s. We've done them excessively. This is as close as you can get to natural material timber, because it is green timber. It is not glue laminated. It's just cut slats. It's not kiln dried, deliberately not, because you actually use it in its bendable form. You bend it into shape and make it into the form it then dries into, in fact. But most often, another one of our projects, rather beautiful, but here you get it, the idea that timber is effectively an engineered material. We have metal connectors wherever we piece the individual parts together, and it becomes a hybrid of metal, glue laminated timber, very far away from the natural product. Here too, there's this push now to stack floors. Yeah? This is one of the first tall buildings, fast up by the engineers for that. In British Columbia, you've probably seen that all, right? Quite an interesting structure, really mimicking what we're doing with concrete, right? The flat slab and the single columns in between. Slightly tighter column grid than in your normal concrete structure, but quite spectacular, I would say. And then this one here, again, is one of my projects. The competition that I won was big a couple of years ago, is now in design. Dock A replacement, Zurich Airport, that's what it looks like on the inside, yeah? I think we're moving timber now towards the same thing as steel, try and push it as far as we can and make that into, at the end, is it more sustainable? I don't know, because the question here will arise in a second. Another building in America, their timber is a little bit behind still, although everything is actually built on a single-story scale in timber. When it comes to multi-story, it isn't quite as advanced as in Europe, I'd say. And quite often when we did studies into where the timber should come from, it was actually cheaper to get it from Austria than from Minnesota or something to the East Coast, just purely because of how the industry is set up. On this building, we did quite intensive research into the various different floor options, and I bring this up so that you can have an idea of where it lands. And here too, right, the timber option, the structure alone, just the floor structure, gets you to 120 kilograms per square meter of floor. Yeah, far better than the concrete option at the other end of the spectrum, which is about double that. And the steel, with different types of, NWC is normal weight concrete and LWC is lightweight concrete. Slightly different, sits somewhere in between. Here was that sort of thing that I mentioned earlier, though. Is timber the answer? This is a study that we were part of, which is published in the iStruct-E magazine, that was looking at, and I'm not going to go through this because it's a little complicated, but it was looking at this kind of cycle of cutting timber, replanting it, cutting it again, replanting it. And at the point where you take the tree out, it can't sequester any carbon anymore. So you take that out of the equation. You have to replant. It takes time for that tree to get to the same level of sequestering than before, about 60 years. And if we then couple this with the idea that our lifespan of a building, something that really irks me, but we design buildings for 60 years. And then what? Either we do what Brigitte mentioned earlier, we turn them into a circular economy and reuse them, or do we throw them away? But if we throw them away, then actually we get to the point that the timber floor is worse than concrete. It's really about what is the afterlife of that timber, because if we burn it, which is very often the only way to get rid of it, because it is full of glue and chemicals, then actually we're releasing the carbon back in the air, and we're as bad as before. So we really have to be very careful how we deal with timber as a renewable source of material. That's its huge potential. But it gets me to something that is quite important. We get to that in a second, about how we design and how we actually go about this sort of stuff. I felt I needed to mention some alternative materials. They are up and coming. Rammed earth is something that's sort of gaining a market share of 0.0001%, but with techniques that are scalable, that are actually usable, prefabricated and all the rest of it. Other stuff, mycelium is one of those that pop up every so often. They never really go beyond pavilion scale. And when I have these kind of studies with my students, I say to them, you can do anything you want, but no pavilions. Because pavilions kind of get you around the real problem, stacking floors and being a little bit more ambitious with the scale. So I said it already, we need to rethink how we build. And the whole industry, that's the good news part of it, has actually started to embrace that. This is the Green Building Council's roadmap to zero carbon. London has its own regulations. We heard that earlier. We need to now prove in London that there is a case for demolishing a building. If we want to demolish a building, you have to usually go to refurbishment or restructure. And the Marks and Spencer piece, the building on Oxford Street, is one of those where this has made big waves. Yeah, it's become a political thing. And I think it is a good thing that it has, because it forces us to think in circular ways, and it forces us to think in what do we do with these buildings. This is a study that I did for Sidewalk Labs in 2016. That was all about future adaptability, because I'm highly doubtful that that 60-year lifespan is a useful thing. And if I go back to that building, on the Broadgate building that we did the embodied carbon study for, what we didn't put into that embodied carbon study is that there were two perfectly good buildings that were built only 30 years before, and we demolished them because the client wanted bigger floor spans. Yeah, absolutely ludicrous if you ask me. And I keep it very quiet that we actually won a sustainability prize for that building. Today, I don't think we would. Yeah, but we did this study here for what needs to happen in order to make a building adaptable. And it was very, very easy to see that the quickest way to gain future adaptability is a loose fit, is something that allows you to not lock yourself into too tight a floor plan or too tight a floor-to-ceiling height. If I go back to this, the 3-meter floor-to-ceiling height, or floor-to-floor height rather, for a residential building, you will never be able to turn this into an office building or into a hotel or into anything other than residential. Terribly limiting. So it's worse, we did a study at the time, to spend a little bit more carbon at the beginning to achieve that loose fit, but it needs to be coupled with a circular thinking, that we build this building for reuse, that it becomes a building that has a lifespan that is way more than the 60 years that we sort of look at or 30 years that we accept far too often. And I just bring this one up. It's probably not the sort of sexiest building on the planet, but it follows exactly what we're postulating. It's for a big bank in the city, and all we did here is look at what can we do with the existing building. They needed more space, and we did a study of what can be done with the frame, and the whole concept is build on it as light as possible so that the foundations and the existing structure can take it. Don't take down what you have, and use where you rebuild frame. And that's actually quite interesting. I'm not going to talk much about technology today. I hope this works with a click here. But we're using all our technology stack in the background in order to facilitate these kind of ideas, that we can very quickly get to an assessment, what a building can take and what we can do with it. That's the future in London at the moment. This is where it's going, and the discussion is all about, I have that with many of my partners, should we build new at all? But with all of that, with everything that I showed you, we get to, let me move on, from the current 750 or so kilograms per square meter for an average building, we just about get to this. That's really kind of pulling it, literally using everything we have at our disposal. It's tough to achieve. We've come close a few times. It's Land Security's 2030 target to get their buildings to 500 kg per square meter. It sounds good. Is a 35%, 33% reduction? It's a shitload of carbon, 500 kilograms. We haven't made a dent into the problem. And we haven't achieved with that what we said we would, that we get to half, yeah? So we have a real problem. And that real problem, I think, has to a large degree has to be solved at the chemical end, at the material science end. And that's where we plug into that as engineers. And I think you as architects going forward in the future need to be aware of that and need to be plugged into this conversation as well, because there is a lot happening. We put a list together of those who we believe are worth pushing. There are 5 or 6 individual startup type laboratory organizations that are doing decarbonized concrete in various different ways. I think some are more promising than others, but at least there is quite a lot of individual push out there that move in the right direction. And the same is happening with steel. That sort of University of Birmingham enterprise thing that you see there is probably the most promising. It has a sort of carbon recycling thing that allows you to produce steel and concrete in a very efficient way with virtually zero carbon and no green hydrogen. Is very interesting. But if we look at where things are going, and that's where I probably don't quite share Brigitte's optimism, because that's the projection of annual cement use. Can one see the map? I think one can see it here better. It's a little faint. But it's going to go up. It's not going to go down. We're not going to replace cement anytime soon with rammed earth or timber or anything like it. And the really bad news is that all the big cement manufacturers, they're sort of banking on future technology. They're banking on it all happening with carbon capture and storage. No one knows how that works. Really? Yeah, we're going to pump it into the old natural gas holes in the North Sea. No one has proven how we get the carbon out of the air without huge amounts of energy spent, but everything is stacked on that. 45%, 44% of the reductions, of the total reductions, are achieved with that, and the full potential only in 2050. We need to decarbonize now if we want to get anywhere near it. And then there's another problem. And that problem is, although world population growth is slowing, And by the end of the century, it's virtually zero. By the time when we've set our targets, we have to house another 2 billion people. Now, if you think that London is 10 million people, roughly, for round numbers, that means you need to have multiple Londons, hundreds of them, in order to house these people. That's not going to happen so easily. And if you look at where this is going to happen, population growth in the next 30 years, by weight, yeah, I like these bloated maps, yeah. Because they show you where it's going to happen. It's going to be India and Africa, Pakistan and Indonesia. I've got this here on a map from 2016 to 2050. Goes a little further back, but I don't think the 2016 numbers are too far out from now. But it gives you a flavor, yeah, that India is going to be the most populous country in the world, 1.7 billion people. Nigeria, that's the most interesting one, doubling in size, 200 million more people, boom, in the next 50 years, right? Quite, not 50 years, 30 years. And if I go to Lagos, and its density, and what it looks like at the moment, I don't think we're going to solve it there with intelligent refurbishment. So we have to new build if we want to do this. This is a study that I found in the Washington Post, Lagos 2015, estimated population, because nobody knows, right? Nobody knows how many people live in Lagos, but estimated population, 15 million, that's the density plot over the city area. Project that to 2100, and it'll be 80 to 100 million people with that kind of density. This is going to be enormous building work that will happen there. If we don't do something about the material, and I don't think we will, in the time that we have, I think it's looking a little bleak, because that's the projection still. So 1.5%, about 1.5 degrees. Do you think we will achieve that?
Definitely.
We have achieved it this year. Yeah, we got there this year. We're very, very close to it. So the Paris target is out the window. Yeah, we're gone. And we're needing to look at this, flooding in California and typhoons and hurricanes all over the world, increased heat waves and droughts, and wildfires everywhere. And they're not exactly good for carbon emissions, right? Because we can save as many trees as we want, and then we have these kind of events all the time. And then the interesting thing that most of our population lives in coastal areas, all around the edge of the landmass. And these kind of maps, they're not going to just happen in Manila and in Bangkok, where you think it's far away. It doesn't really matter to us here in Blighty, yeah? But London is also going to be affected. And so is New York. And the question that I'm asking myself is, what does that mean for us, for architects, for engineers, for everyone in the room here? Because this is our future. I'm probably just going to be scratching the sort of tail end of it, but I'm too old. But it's your future. And in a way, it's challenging and it's brutal, but I think it's also an enormous opportunity to reinvent architecture and reinvent how we build there and what we build. And that's sort of what I want to sort of challenge you with, because I Googled climate resilient architecture. That's what I think what it says here. Architecture for climate resilience. And then this bullshit comes up. Unbelievable, excuse my German. It's just sticking trees on buildings. Is that the answer? Or that? Or is it this, that we build a dam around New York? I doubt it. probably more like this. But anyway, it's a blank sheet of paper. Over to you.
They're making gestures about rowing out between buildings. Questions? Anyone? They're all smiling.
Are you smiling, or you're going, or you're gonna go slap your wrist, slash your wrist? Yeah. I don't know. I had a talk once in our office by Hugh Montgomery. He's a professor of intensive care medicine up here at UCL, and he started the whole thing with a joke. He said, one planet meets the other and says, how are you doing? Oh, I'm fine. How are you? Not so well. Yeah, what's wrong? He said, I think I've got Homo sapiens. And the other planet said, oh, that hurts. But don't worry, it doesn't last long. Any questions?
Hi, is it working?
No.
Thank you for amazing presentation. There has been a lot of talk during this week about the kind of conscious decisions that architects and clients have to make in their projects. There has been talks about how architects have to convince their clients into more intelligent ways of building more intelligent materials in terms of sustainability. But you are positioned in a different place as structural designers, as structural consultants. Am I right? How do you see yourself in that kind of dialogue? Do you suggest these kinds of, alternative methods of building to clients or to designers? I mean, you're a third voice basically in every project, right?
We're sort of at the beginning here of a journey. I use my voice wherever I can to push for the material development that we need in order to move the dial. And I use any one of my clients, whether they want to hear it or not, and tell them that they need to invest in this. But we're also driving actively what I showed you here, yeah, that it might get a little boring, yeah, just doing the refurbs and doing the remodeling of buildings. But I think in places like London or Vienna or Berlin, God knows, yeah, in Northern Hemisphere, in Europe, where population is either stable or declining, we don't necessarily need to build new. It's bordering on capricious if we build new. What I find much more interesting is to see how we develop models for those countries that are still 2 steps behind on that development curve. And where I see absolutely no justification that we should deny them the opportunities to develop just because we did it at a carbon cost. So we need to push for this development of the new materials. At the same time, I do think, and I'm speaking here as an engineer in a multidisciplinary engineering context and not just as a structural engineer, I think we need to develop the concepts for resilience and the placemaking that is needed in order to make cities in those areas that are affected, or all over the world that are affected by climate change, livable. Because I've not touched on any of the other challenges of sustainable mobility, of social inequity, and the need to create places that have a high livability. I haven't touched on that because I would talk for another hour and I was ran out of pictures. So I see this as a dual challenge, basically, yeah, to drive, or actually it's a triple challenge. Drive the circular economy piece wherever we can, drive the development of new materials and new solutions, lean solutions, wherever we can, and at the same time have an eye on that last bit that I wanted to get to. Without that resiliency piece, we're nowhere, because we will not solve it. Absolutely not. Not in the time that we have.
I think you've silenced everyone.
So it sounds all a little negative for you, I fear, yeah, because it's so silent. I see this really as your big moment. Architecture needs to completely reinvent itself. And you are at the beginning of this journey. I have not seen any real convincing answers that have emerged. There is little nuggets of good solutions. There are interesting thoughts, but a whole lot of stuff that I see out there is window dressing at a massive scale. You had a question over there.
Thanks for the presentation. So, you showed us the evaluation of carbon, and that is becoming more of a common practice now, that you are mapping how much carbon these buildings are consuming, even the embodied and the life cycle of it. The other thing that sometimes worries me is, I mean, concrete uses a lot of water. And we are running out of water. Like in countries like India, there are places where we don't have water, and the construction industry, predominantly based on concrete, is the major user of water in a way. Are there, I don't know much about this, but are there attempts to map or calculate water consumption in the construction industry, and what are your views about it? And what materials in that sense are sustainable in terms of water consumption? Because we are going to run out of water in a lot of places.
I think you're bringing in an incredibly important aspect that is totally neglected at the moment. We're not looking at that at all. We actually don't even look at the waste stream that I had a little sort of pie chart in there as well. Almost 50% of all waste created is created in the construction industry, out of stuff that goes to site and doesn't get used, or buildings being demolished. Add to that the water challenge, and all of these are currently kind of drowned out almost by the carbon challenge. And I think it comes to a point where we need to see all these. I'm really grateful for your comment here, that we need to see these all in as part of a systemic problem of how we build. It comes back to what Brigitte was saying in a way: extract, build, and then bugger off, basically, yeah, and don't care anymore. It's not good enough. The challenges are big, and I think the challenges will become bigger because in all of this, the reason why we run out of water is primarily because there are 8 billion people on the planet, and there will be another 2 billion in 30 years' time. We have massively overpopulated this planet in many ways, and we've driven the resources or the resource use to the absolute edge. So yeah, we need to have solutions for that.
You're looking at me, but I don't.
No, I'm not looking at you. No, I'm staring in the.
I don't know. But yeah, I mean, we started the week with this conversation, that the Malthusian problem. Malthus was the first guy to try and calculate how many people could live on the earth. So we call it the Malthusian problem.
Mm-hmm.
And some of us view it as intractable. I also don't share the complete optimism that we're going in the right direction. But I do have a kind of optimism that architects are capable, in your generation, of reinventing how we do this, but it won't be on the same trajectory that the world is on now. It won't be life as it sounds like Star Trek. It won't be life as it is now. So part of that reinvention is going to be how we live differently. And I think that's a principal question. I think there's also a problem with the word sustainability. We've seen some diagrams during the week where we're trying to move past that notion of sustainability. Sustainability implies that if I have some amazing new invention and change the way we do things, we can carry on as we are. So in that sense, humans are not sustainable because there's so many kinds of change that are needed. I think it's much more what we saw earlier, people talking about restoration and then regeneration. So the kind of fun, I think, you know, Wolf's blank sheet is terrifying.
But it's also an invitation, right? I mean, you asked the question how we as engineers see this. And the biggest mistake that we can make is that we trivialize things. And I see things trivialized in architecture all the time. Yeah, we've got our red arrows in and blue arrows out, or the other way around. Yeah, but then and all manner of kind of sustainability tropes that we layer into architecture, which mean absolutely nothing. But all of this is actually coupled with science. It's all possible to engineer this. But we're engineers. Yeah, we're not the designers. We're not the ones that then drive the, dare I call it, cultural aspect that architecture brings. We are the technical experts behind that. But to solve a challenge that is part chemistry, part environmental and weather and temperature and comfort, and part cultural, that blank sheet is for me and you to co-create. We need to do this together as a joint effort between those who can tackle the technical aspects and the architects that can come in and bring the cultural and the livability. I think it needs to go beyond architecture as well. It needs to become I call it transdisciplinary, beyond multidisciplinary within our industry type collaboration. If we really want to move towards what Mike just mentioned, that we need to change the way we live or create the environments that support that change. Because we can't change the way we live if we don't support it with the right environments that we are creating.
So we've left the world in a terrible place for you to inherit, but also believe that you can make those changes. But they're much broader than, as Wolf is showing, they're much, much broader than the architectural industry or material industries as we show it now. I think tomorrow night we'll try and round up all of these things and address those kind of bigger questions. But reinventing architecture is not a continuation of the profession as it is now. It's just not going to work.
It can't be. Yeah. Thank you. Oh, there's another question. Oh, wow. I thought it was over.
Okay, thank you for the amazing presentation. And in the presentation, it's talking about the future adaptability of the building, which kind of like making the lifespan of the building longer. But the truth is, like in reality, there's like almost no building could reach the time of their like kind of lifespan. They're kind of like destroyed or kind of like teared down like in maybe 20 or 30 years. So
that comes back to the question that we had earlier about what we value and what we don't value. And this thing here wasn't torn down. It was just adapted.
Yeah. So
This building here is from when? 1800?
Yeah, about 1820.
1820. There you go. 200 years old. Yeah? And I think we need to design our buildings so that they can be 200 years old and we still love them. And that's an architectural culture question. It's not a technical question. We need to do the loose fit. This thing has a certain loose fit and therefore it's quite adaptable. It's pretty bad as a lecture hall, but we put up with it because it's quite a lovable building as well, right? So I would never design a new lecture hall in this kind of arrangement, but I would design a lecture hall that is such a tight fit that it can only ever be a lecture hall. This was an entrance actually, right? Because there were two buildings. But you get what I'm trying to say. We need to, this is a rethink. If we take buildings and we treat them as assets that we write off or amortization period of 30 years and then bang, we can't afford that. We just can't afford that.
Yeah, when I was a student, when I first came here, I was told the average lifespan of a contemporary building is 20 years. That's what you designed for. But actually it earns its money back in the first 5 years. And that's all you should worry about as an architect, is those 5 years. And after that, it just kind of decays. And I was also taught in terms of urbanism and cities, that they were just a sort of material residue of economic activity. Yeah. The principal task was making money in the abstract, and buildings were just the kind of leftover stuff of the money making. So in one sense, there has been, thinking about what Bridget is saying, a big change in consciousness, but it resides largely in your generation, and your generation being a little bit older than they are, but just a small amount, and is not yet widespread. Good. So tomorrow night we're going to try and round up these all conversations and all these views that have come during the week. So I'm hoping you're there and you'll be part of the fiercer debate.
No, and thank you for your questions.